Hello, this is Mrs. Carpel, and in this video we are going to identify if functions that have been represented either by a graph or in context are discrete or continuous, and define the domain for the functions. In this first graph, we have a graph of plotted points. A graph of plotted points is a discrete function. Another way that I use to remember that is discrete and dots both start with the letter D. So on a discrete situation, you would have dots. Our domain appears to be all of the integer values beginning with 0 and continuing on, as we can see a partial point yet at the top there. So we can define the domain because it includes 0 as the set of values x such that x belongs to the set of whole numbers. So in words, we can say that the domain is the set of whole numbers. Whole numbers are the numbers 0, 1, 2, 3, 4, 5. They do not include any negative values. In this second graph, I see part of a line, and this line is starting on the y-axis, so I could say that it is including the value of 0. Because it is a line and not just individual points, we described this as being a continuous function. Continuous means we can take our pencil and we can trace it without ever lifting it. The domain in this case isn't just the set of real numbers, but it's the set of x values such that x is greater than or equal to 0. So that's all of the real numbers greater than or equal to 0. You could even just write in words that the domain includes real numbers greater than or equal to 0, because we can include any decimal and fraction answers. This graph is another graph with points, so this is described as being discrete. We do not have any points on the y-axis or to the left of the y-axis, so in this case our domain are all of our counting numbers, 1, 2, 3, and so on. We call those natural numbers. So our domain is x such that x belongs to the set of natural numbers. Or if you just want to write out the words, it is the set of natural numbers. Now let's take a look at some context. A sample of mold doubles in size each day. It initially covered 0.25 square inches. Well, mold doesn't just grow in specific increments, like it's one size 1 minute and then it waits a whole nother minute before it changes size. It is continually growing, just like as a young person, you are continually growing. So we call this a continuous function. And because we're starting with an initial size at time 0, we would define the time as being x such that x is greater than or equal to 0. Or you can say real numbers greater than or equal to 0. Here we have each hour a bird adds 2 more pieces of grass to its nest than it did the hour before. It started with 5 pieces of grass. Because we're just adding 2 pieces in the hour, and it's not like they're pulling grass off of like a skein of yarn or a roll of string, a ball of string, it's happening in increments. So this would be a discrete situation. And again, with time, you're going to have that domain include 0 and everything greater. So x such that x is greater than or equal to 0. Or again, you can say the real numbers greater or equal to 0. Here we have a doctor's office has a basket with stickers for children. There were 150 stickers in the basket. Each hour, 4 stickers are removed. Again, because the stickers are not being pulled off of a roll continuously, this is going to be a discrete situation. And its domain, again, we have a starting time at time 0. So we're going to say, because it's discrete, we're not going to say that it's all real numbers. We're going to say that it's some sort of integer. In this case, it's the set of whole numbers. Because we're including 0. So x such that x belongs to the set of whole numbers. In the situation of a car driving 55 miles per hour, it's like the car is on cruise control, this is going to be continuous because a car is constantly in motion once it's put in drive and the brake is not applied. So this is continuous. The domain can include 0. So x such that x is greater than or equal to 0. I wouldn't want to include any values less than 0 because that would be taking me back in time, which we can't do right now. So real numbers greater than or equal to 0. Now you want to keep in mind that domain is defining the types of values we can use for the input values. So on a graph, those are going to be your values along the x-axis, and that's why you see me using x whenever I define my domain. And this concludes our video reviewing discrete and continuous functions and defining their domains.